I have the pleasure to introduce Dr. Tom Rondeau. He's the Principal Director of the Future G Office for the U.S. Department of Defense, serving in the Office of the Undersecretary of Defense for Research and Engineering. In this role, Dr. Rondeau is responsible for the research, funding, and execution of programs to advance warfighting capabilities using future generation wireless technologies. And with that, I'm going to pass it on to you, and then he's going to get your slides up.
Thank you.
You're very welcome.
Yes.
Yep. Nope. This one's separate. It's for the camera. You got it.
All right. Good morning, everybody. As Laura said, I'm the Principal Director for Future Generation Wireless Technologies, or Future G. And so I'm going to talk to you today about how the DoD really should be looking at using open source software for benefiting our efforts for national security, defense, warfighting, et cetera. So my background, for those who don't know me, I spent a long time running the GNU Radio project. So I was involved in that since my graduate days, took it over in 2010, and really watched the change that happened in the wireless industry because we kind of broke open some of the mysticism of RF and getting it out of the textbook, getting out of the simulation, putting it really into the hands of people to experiment, to explore, to understand what's going on in the wireless space. I often joke, not really joke, but the history of where we are today in both computing and RF all traces its way back to the invention of the transistor. And for those who know this, right, the engineers in the room, the transistor was designed, was implemented to replace vacuum tubes as an amplifier. They wanted a solid state amplifier for RF to find out, to get really small signals, better propagation, better production, better supply chain, et cetera. It was quickly discovered that you could use this transistor to do Boolean logic and make computers out of it, and those were better than the vacuum tube-based computers as well. And then the computer industry shot forward incredibly. Everything just changed after that moment, and computing is where it is today with all the innovation, all of the advancements that have happened there. But then if you kind of look at radio is kind of stuck a little bit with only the people who really understood how to harness this transistor for RF performance. So you have the Motorola's and the Watkins Johnson, and then the Ericssons and Nokia's, and then people, it was really esoteric knowledge, and so it took a lot of effort and a lot of work to make it work as an RF system. And so you have great engineering work being done in the RF space, but it was magic. So I always like to think that what we did in the software-defined radio world is we've taken the transistor as a compute device to unlock the transistor as an RF device. And so now we get to program the electromagnetic spectrum and do all sorts of really fun, innovative things with that. So once you take RF and break it down into the pure math that we've studied, and then you implement that math in a computer and manipulate these radios to do what you want, you get to do a lot of really cool stuff. So innovation is the really key driver of a lot of this vision here for me. So on top of that, we're also looking at the cellular standards and why are we involved in the DoD and 5G and future G technologies. A lot of that comes down to the fact that when we moved into the 5G world and we became a software-defined networking features of 5G, that was that was a revolution on top of what 4G was doing, which is providing a very good service that was really just a bit pipe, from a tower to a phone. And as I say, it's almost just like an Ethernet plug without the actual Ethernet cable. 5G allows you to tailor your solutions to different problems, and it's much more definable, it's much more software programmable. So that opens it up to a lot of possibilities, because every problem in the DoD, we funded a very niche solution, a niche data link or radio type or networking function to it. But now we can start adjusting these networks to special purpose for those different niche applications that 4G and previous generations weren't really right for. So a lot of opportunities here, but we need that innovation spirit. We need to be able to dive into these systems, understand how they work, deploy them, use them in the field, get them operationally relevant, And so we need a lot more hands-on. We need a lot more in-depth knowledge of how these systems work. And so breaking open that code base is really critical to us. So that's a little bit of kind of philosophical background from my perspective on this. What the office itself is doing is looking at the needs of the department and realizing that our desire for communications and what we need to communicate in the field, operationally, tactically speaking, far outstrips our ability to produce solutions in a classical DoD contracting acquisitions model sense. As I often say, if you need to build a fighter jet, come to the U.S. Department of Defense. We'll build the greatest one in the world. We'll fund our traditional primes, Lockheed Martin, to build the F-22, the F-35, the next generation aircraft. When commercial industry knows how to make money off of something, like a lot of money, $1.6 trillion industry is what the cell phone, the telecommunications has turned into, it's hard to stop you. It's hard to stop the invention from happening out there. So how do we take advantage of that? How do we look at industry and the change that's happened out there over the past couple decades and bring that into our purposes? But it's not quite enough to just take 5G, either existing cellular network or slap a 5G modem onto one of our military platforms and call it a day. So we have to figure out what are the changes that need to be made, what are the features that may need to be tweaked a little bit. So we say here, advance, adopt when we can, adapt when we have to, and also innovate. And so within the department, we have the 5G cross-functional team that belongs to the Chief Information Office. I work for Research and Engineering as the Future G person. So you'll see a lot of the adoption and the deployment of 5G coming out through DoD CIO and through the CFT, whereas we're really looking to that next generation. Okay, what are the research problems left for us to work on in 5G, and what's the innovation that we need to produce for the future generation technologies? So we're heavily involved in 6G. We're working across the interagency, so with the rest of the departments within the U.S. government, with Congress, with the National Security Council and the White House, all this to try to find a new vision and a U.S. led vision of 6G. And then we've been socializing that and working with our partners and allies around the world. And so we look back to, it was late February, right when Mobile World Congress Barcelona happened, the White House produced its joint statement on a vision for 6G. And that was done in conjunction with 10 other countries. So we're really trying to pull together a new vision for, again, what 6G could mean and what it can do for us from a societal perspective, from an economic perspective, and for me from the DoD perspective. So to then build that, to craft that vision into executable, operationally relevant concepts, this is our overview slide of the office, and we have 5 major themes here, five lines of effort that help us match research to need for the department. So starting over the resilient open commercial solutions. So having recognized that commercial industry is progressing so much faster, how do we take advantage of that? And how do we push things like resilience? And that goes back to that joint statement on 6G. Open, secure, and resilient by design. So resiliency is a key feature here. And so we have projects going to work with industry to try to make a more resilient network solution. We go over to ubiquitous, secure, and instant access. And this one, ubiquitous, is a vision that cell phone industry and anybody in this world has been striving for. Wherever you are in the world, how can I make sure to get access to the internet and to my data? We're adding the secure and instant to make sure that, again, wherever we are in the most austere conditions in the world where we often find ourselves, we can make sure that we securely access the data. And that is a huge part of the challenge here, is to ensure security, ensure that the information flowing between commanders and warfighters is trusted, is timely, and is delivered appropriately. So ensuring some of the security features of this has been a huge part of our effort in the office. Over in expeditionary and tactical use, this is when you go into actual conflict, and there, we can see this in what's happening in Ukraine, the electronic warfare that's happening out there. So we talk about congested spectrum in a more of the kind of civilian world, where everybody wants access to more spectrum. It's harder to come by. There's plenty of existing users. We also have to deal with contested spectrum, where you have an adversary specifically trying to attack your communication systems, whether or not it's jamming the GPS links to the actual communications links themselves. Cellular, tactical radios, C2, the command and control to UAVs, all those are under attack. How can we survive using this technology, or can we survive? Really, it's a research question of is this applicable to that? And when it is, how do we use it? When it's not, how do we ensure that we know that and make informed decisions? This one is also big with our interoperability with our allies and partners. So we're working closely with a lot of countries around the world. NATO is a big partner, so all the NATO countries, we've engaged with them. We have 5 really close countries we're working with there. A lot of work with South Korea and developing more with Japan and Philippines and so on. All right, so then we move to integrated sensing and communications. This one's really fun, and I think this is again where research is the name of the game right now, and the ideas that I think can be cracked open with this ISAC concept. Now that we have access to more spectrum, so as we're now thinking about opening up the FR3 band, the 7 to 24 gigahertz band for future cellular standards, and so 6G will start using some of those bands. We've got FR2, right, the millimeter wave stuff. We got the classic FR1, low band, low mid band stuff. Those are all opportunities to use spectrum for new ways, not just standard communications. We also have a lot more embedded compute power at our fingertips, and so now you can actually make more sense of the information coming in from your radios. So as we've built up this incredible network around the world of radios, transmitters and receivers with access to all the spectrum, with a massive amount of local compute power, now it's not just decoding the information into bits and passing it along. There's information about our surroundings that are embedded in the signals themselves. ISAC says, let's make use of that. Let's turn that into useful information as well. A lot of opportunities here from an intelligence and surveillance and reconnaissance perspective. I think possibly a lot of commercial interest in this. A lot of public safety potential in here as well. One of the ones we think about is drones. Swarms of UAVs moving packages and goods and medical supplies. We're seeing that all over the world already. In the U.S., we haven't really gone terribly far due to many reasons. But one is, how do you control? How do you track and have traffic control on a system like that without having to maybe deploy an entire specialized sensor system just to enforce traffic laws on drones? Maybe we just buy it from the cell companies, and they can tell us what's happening there, and we can use that for enforcement. So really interesting ideas to come out of this. We're just really kind of cracking open some of those in my office now, but this is one of the more exciting areas of invention that I see. And then finally, I'll talk the smart, resilient logistics piece of this. Now, this one's really interesting because the U.S. military, the U.S. Army really is the most complicated logistics problem in the world. How do you move all those people, all those goods, all the repair parts, monitor everything, keep track of everything, and keep a functioning standing army? The addition of smart warehousing, smart deployments, trackers, information flow, and local compute to keep tabs on things. All those become a smart, resilient logistics concept that can be transformative for how we do business in the Department of Defense. So a lot of interesting work that's going on there. So what I then did is, okay, we have all these kind of grand vision ideas. How do we execute on any of them? So we've made some specific projects here, and so we've defined our priority efforts, and we'll be updating these for our 2025. But they're going to be evolutions of these ideas, because we're really starting. There's so many good things that are happening in each one of these areas. Let me start off with the RAN sharing project. This one is if there is 5G, future G technologies, networks that are deployed out there, how do we make use of them effectively? There's different models for engagement on these types of systems, from I can just buy a SIM card or get an eSIM when I go into another country and use it, to I can build up my entire parallel network and operate it myself and build that if I wanted to things like sharing some of the infrastructure, performing a virtual network operator type model on it. What does that look like with different countries and for different purposes? We're also working a lot with NATO, and the Latvians have built up on their range, the OSS range, the largest military range in the Baltics. So we've been working with them and early on, the Latvian Mobile Telecom realized there's a lot of other uses for 5G than just providing cellular service to you as customers and consumers. Let's start looking into these. And so they actually deploy multiple 5G networks on this range. And so we're working with them and with multiple countries throughout NATO to see how we can exercise and utilize these technologies for joint interoperable NATO engagements in the future. Under integrated sensing and communications, what I was doing there is as we've been doing our research and talking to people, and we're probably going to have a workshop on ISA coming up in the next few months to try to really understand the potential for this technology area. What's possible, what's marketable, where do we think the commercial market's going to drive that technology? But I realized, much like I talked about with Good New Radio and the work there, to open it up and expose people and let people explore, we needed a place to explore integrated sensing communications. And so we've been working with the Air Force and with New Mexico Tech to take a small town in New Mexico that was abandoned decades ago and turn it into an information warfare range. So we're adding on to this town more infrastructure. It's got connectivity. It's got livable spaces. People do actually live there now who work on this range for multiple purposes right now. But one of them will be deployment of our 5G systems down there. Multiple different networks connected up across the country, kind of focused there. And now we can start to play. We can start to experiment with live, over-the-air experimentation, because I think in the world of this integrated sensing and communications, you have an idea, it seems to work on paper, you put it into a simulation, looks great. Take it to the lab, suddenly doesn't work. Fix it in the lab, take it outside, definitely not going to work. So how do we make sure that we actually have the place to run through those reps in order to get working solutions? So the big one, I talk about some workforce development and microelectronics comments on the slide, but let me focus on the big one here, because that's what's going to dominate the rest of my talk here, is this open centralized unit distributed unit, what we call OCUDU. This is the big effort with commercial industry trying to kind of leapfrog into a 6G era that breaks open, not just open RAN, not just kind of disaggregating components of the RAN, but actually opening up the code and making sure that we have a secure, resilient, robust code base for the future of telecommunications. So I'll get to that more in a second. But I did want to at least make highlight some of the work that we've been doing. We're here at the SRS workshop. So my office has been working a number of research projects across the US on how to use all sorts of 5G technologies. And many of them are using srsRAN as part of their core tool set. And so Georgia Tech Research Institute, one of our university-affiliated research centers that works a lot with the DoD, they've been integrating srsRAN into their products for the last couple of years. They've actually been working with multiple different vendors, chipset vendors, radio vendors, et cetera. So again, we can understand how it plays and helps us focus on some of our specific needs, such as how do we do kind of expeditionary use of this technology? How do we fly these types of technologies in order to support our troops? Northeastern, they've been running the Open 6G program. So this is Tommaso Melodia up there. And so they've been studying all sorts of ways to utilize these tech and try to figure out the right technologies for defining an open 6G solution. So they've been working with open air interfaces and SRS and actually combining them in many ways to actually show that they can work together, kind of proving out a lot of both capabilities of both software bases and also the utility of an open RAN type model where things can be used together. And finally, we've been standing up our Naval Information Warfare Center in the Pacific, or what we call NIWC-PAC. They're one of our kind of premier research and engagement groups with Navy warfighting capabilities. And so have a long history working with them. They have a long history in the cellular world. So we've been helping them kind of build up their future G test bed, and they've been working closely on the SRS code base. So lots of interest in kind of pursuing this technology and what we're doing in this area, and studying and making sure that we've got our hands on and knowledgeable about a lot of this work. Because that's really what a lot of this comes down to is we need more people knowledgeable about 5G use cases, applications that can, and how to tailor your solutions to them, as well as the code itself for different levels of engagement and different levels of education required to get different things out there at scale. Because that's one of the key things here is how do we take research from the lab and get it out there at scale. So moving into this Okudu initiative. So why is the U.S. doing this? Why are we investing U.S. money into this project? And specifically, why is the Department of Defense trying to lead this as an effort? When we look at the future of telecommunications, and again, we're breaking open the RAN, we're trying to get more innovative because of Open RAN, trying to incentivize more people to build different components there and to create new ideas for how those components integrate into Open RAN. We need to take that another step farther, as I already mentioned, and open up the source code. So these buzzwords down here at the bottom are all the things that I think about with why open source matters to us and what this initiative can do in telecommunications. So start off with secure. And this is an interesting one, right? Because there's a lot of FUD, right? Fear, uncertainty, and doubt out there around open source software. People thinking, oh, it's poorly written code, it's just code somebody wrote in their basement, or because it's open, everybody can find the bugs and see and exploit those bugs. Those are both myths. So yeah, there are some kids that write code in their basement and try to deliver it to products, post on GitHub. But true open source code bases, the ones that have a lot of use, a lot of users, a lot of backing to them, these are professionals working on the code. The code is generally well written because it has to be read by so many other people that it drives towards readability, and readability tends to drive towards faster time to solutions and faster times to fixes. It also allows us to patch and deliver patches very effectively. Typically more effectively than a lot of the proprietary solutions we've seen in the market. I think you could look at the Log4j, which we actually did, the US did an analysis on that, and it was within about 2 weeks, Log4j was used everywhere, and there was a massive vulnerability discovered in it. And within 2 weeks, over 80% of all Log4j instances had been patched, versus something like SolarWinds, which is a proprietary solution, which took, was a lot more complicated to roll out. So thinking about this from a security standpoint, commercial best practices are trending towards more secure systems. we're trying to make this transformative. So this is our word for innovation. Right? How do we transform the industry? As I like to say, what Linux did for the internet and Kubernetes did for cloud, we want Okudu to do the same transformative concept for telecommunications and wireless networks of the future. We talk about resilience. Again, how to fix things, how to patch things, how to build infrastructure on top of things, and you need to have intimate knowledge of code that maps to the hardware, that maps to your application space. And so in different solution spaces that we require in order to have redundancy, this becomes one of our drivers. So without trying to hit on every one of these, I wanted to hit on those top ones. But importantly, we go down to interoperability, and this is a key challenge for us. This has been a challenge in the first responder world. It's been a challenge in the military as everybody bought their own tactical radios and their own push-to-talk systems that weren't compatible with each other. Now try to go over to NATO and have 32 different countries agree on one thing. They're standards, STANAGs over in NATO terminology. And we do have them, but every country wants to have its own kind of sovereign solution, and they want to be able to build towards that. So we look at 5G and future G as that software-defined networking can actually help pull those disparate systems together. And we've all kind of already agreed on it as as an international standard. So this is how we're focused on using it. And all of these challenges that we have, investigation of code, code practices, management and governance, all those things really come to bear when we think about why we want to stand up this project. So I talked a lot on this slide, mostly about the software aspect of it, because that really is going to be the focus of a lot of these of the Okudu effort and a lot of what's necessary here. But we also have two other parts of Okudu. One is hardware. So we want to focus on interoperable hardware and virtualization. So what the SRS team has done is made an incredible use of the silicon that comes off the shelf and have really shown how you can take advantage of that effectively to get high-speed, high-quality systems. But there are opportunities for advancements in silicon for hardware acceleration of different parts of the math problem that is these 5G future G systems. And so we'd love to be able to offload certain hard problems, especially as you get closer to the antenna. The sample rates go up, the computations become harder. We've seen there's a handful of solutions out there for offload to accelerators, mostly for the LDPC decoders. We want to be able to keep incentivizing industry and our academic research friends to try to identify novel ways of providing high performance, or another way to look at that is lower power. Energy efficiency is really important to us, both as a U.S. interests in power efficiency, but also when we look at it from the military, more power efficient systems means fewer batteries, less fuel, more survivable, more long-term solutions. So for all those reasons, we're interested in this hardware virtualization problem. And then finally, management. So we need somebody to kind of take an open source software code base that eventually is not owned or run by the U.S. government, not funded by the U.S. government, but commercially viable and transitions to commercial supports. Much like we see other open projects, Linux, Kubernetes, two of the big ones. So we still need knowledge of how to use this within the department, and so we've been working with GTRI to understand how we would manage the infrastructure, manage it within the U.S. government, but also how it applies to DoD problems. And so we need that expertise. So we're building all of these as part of our Okudu effort. So that turns into kind of this structure here about how these three pieces work together, and again, how we're going to build and work with industry and work with the open source community to try to build a better infrastructure for us and you all and everybody to be able to take advantage of, so that everybody can get access to this useful code base to solve their problems and to create opportunities for your new idea and your new innovation. So we'll have in the middle here this commercial open source manager, but then, as I mentioned, we need government and DoD knowledge for how to use this. So we're building up that infrastructure as well, so that the Okudu manager can deliver this to commercial solutions. So hopefully we'll find appetite, and we've been told that there is. If we build it, people will start to use it. So we're offsetting the risk of commercial industry to get to the point where they can use it. If it is ready, then integrating that into a large-scale systems integrator to deliver solutions to the market, both private markets but also public MNOs at the end of this. Now, I mentioned here standards influence. This one's interesting too, because that's, I think, a useful part of the challenge that we can get into, which is how do we influence the future standards? How do we make sure that we can take the new best idea coming out of our academic institutions, our research institutions, our small businesses, and make sure that they can be well represented in the standards bodies? Again, this provides that transparency and the ability to experiment, get the data, get the evidence of your next best idea to be able to change the pace and the representation that we have in the standards bodies. So for all that, we're pushing this model to kind of kick off the commercial interest in this space. I'll mention here, I glossed over it earlier on here, but I'll mention here this Microelectronics Commons. So out of the CHIPS Act that the US passed a couple years ago, the DoD was given $2 billion to invest in microelectronics in some way. And our way was to create the Microelectronics Commons, where we've invested in 8 hubs around the country, looking at different areas of technology, and 4 of them have a focus on 5G, 6G technologies. So how can we transform our, from an idea in the lab to executing in a fab, novel approaches to solve 5G, 6G problems? And so a lot of that's going to be in this power efficiency that I talked about. So how do we create novel solutions to the challenges that 5G, 6G processing presents to us? And how do we also make sure that we're opening up access to spectrum? We all want wider bandwidth. We all want higher linearity. We want access to more, instantaneous access to more spectrum. So we're investing in, new materials, new designs, new architectures for these microelectronics fabrication facilities in order to open up all of those possibilities so that we can have access to whatever we need. So what we're trying to do here is ensure that our Okudu effort, as we drive that forward, is also informing the Microelectronics Commons about what we actually need to be producing, again, to kind of offset the risk of industry so we can solve problems for them, deliver that to the fab, and let industry do what it does best, which is creative solutions that make money and become sustainable. So what we did last year to kind of set up for this, to make sure that we were doing a well-informed approach to defining this project, is to release a request for information, and had industry, a number of representatives from industry, including SRS, delivered their ideas for how to make this happen, and ideas for what are the feature sets that could be delivered or that we really need in order to make a viable product for commercial or DoD purposes. So when the NIWC team took in all those the solutions that were offered, or the information returned, looked through them and just kind of defines these features as what the DoD really wants to drive forward, or would need if we were to take a solution like this seriously. And so you can just read them for yourselves there, but it does set the stage for where we need to where we need a solution to be before we would be kind of done and ready to integrate this with any other military solution. So hopefully these all make sense. Probably no surprises there. Actually, maybe the surprise might be that we're not really shooting too far into what's possible, but really we were looking at what is necessary for us to work on. Actually, before I move to the next slide, I do want to say the ADAS, which is the United States standards kind of inputs into 3GPP, they represent a lot of US industry in the cell phone industry, or in the cell phone world. And so NTIA, which is executing its own money to invest in Open RAN and 5G technologies, they worked with ADAS and said, hey, we all need kind of this minimum viable, what they call the minimum viable profile, because Open RAN is so difficult to test. If all solutions are possible, how do you run through all those tests effectively? And if you know the cell phone industry and the telcos, reliability and uptime and maintaining call service to their customers is what they care about most. If they can't test this to their level of certainty, there's no way they're buying it. So the MVP was, okay, how do we really define a solution where we can say, here's what's necessary, here are the tests to prove that, and then not have the whole world of Open RAN necessarily available, but at least what's minimally viable for commercial use. So we're making sure to work with ADAS and to keep an eye on that to inform this as well. And so that leads us to the commercial grade features. So not just what the DoD requires from the field, but if we were really to push this commercially, what is the minimum capabilities that we would need to get to before we could feel reasonably certain that that this is acceptable and that we could transition this as a product to create that new kind of revolutionary base for 6G. So again, not going to read these to you, but again, should be pretty obvious in some cases. And as you can see here, sometimes in this one we're pushing farther than what the DoD was actually looking for, just to make sure that we were, again, addressing commercial needs. So a little bit of a timeline here, just to give you some sense. We are looking to, right now, we've been doing the industry coordination, ensuring that we have across US government support for this, and that industry as interest and support as well. So we are looking to get most of this started and a solicitation, getting it up and running as a funded project within the next 6 months to a year, so into FY25, which we just started yesterday. So that's gonna be a big push to try to get this solution started. And then we'll get into a few phases of development and rollout. The intention here is to have this ready by 2027, so that we are watching the evolution of 5G standards into 6G and the 3GPP release process, and eyeing the 2028 time period for when we would say this is the 6G standard. This release becomes the 6G standard. Expecting then about 2030 to be about when you'd start seeing the first 6G commercial rollouts. Now, this is all predicated on the kind of 10-year cycle history of most of the generations and how long it takes to develop a generation of technology. That could always change, plus or minus a couple of years, depending on how fast we really want to move or how fast industry really demands these, right? Do we really want to replace all of our old 5G systems with 6G after we just spent billions of dollars to install that and really still want to recoup our money? In this sense, we're trying to say, let's go into information communications technology, more of an IT type approach. Let's have regular rollouts, not every 5 years completely revamp your system, but more regular updates and upgrades, and let the software start driving what the hardware requirements are. And so now you have more of a softer approach and a different, it changes your model of your CapEx investments. So that having been said, we're still eyeing about the 2030 time period of when we want this to be ready, which means we need to have a product ready, minimum viable product ready in 2027, so we can offload this to industry, say, okay, this will work for you. Who wants to adopt it? Who wants to start pushing it into the labs? Who wants to get it tested? Because again, the network operators are going to need a lot of testing on new solutions in order to be comfortable with them. So we need to make sure that we're engaged in that early and have it set up for that time period. So these are our priorities, and I think I've spoken to all of these issues throughout the course of my talk here. This is designed to be a partnership. An open source community is a community, and it has to take all kinds. The DoD historically has not been a good member of these communities. We've been good consumers of a lot of open source technology, but not necessarily producers and leaders in it. And I'm trying to change that model, because if 80% of all code or commercial products are have open source code in them, and of that, 80% of their code base is open source, and we in the DoD are not doing the same, and we're not taking advantage of that, we're missing the trends. And so I'm dedicated to making this work as a collaboration, building the right ecosystem, building the right communities here. So if we can do this right, we'll design that platform for future innovation. We could transform the static rollouts and sometimes very conservative approaches to technology development and really start to take advantage of the speed and the knowledge and the base of expertise that we can we can port to this. So I of course mentioned the now ubiquitous AI/ML. But that is important, right? That is going to be a base technology for future generation systems. Inside the networks are getting so complicated that we're going to have smarter brains sitting in them to manage them and optimize them. There's huge opportunities for energy efficiencies if we can take advantage of that. We're also going to see AI/ML at the edge, integrated sensing and communications. Probably going to use a lot of that. A lot of the knowledge of our surroundings, or the ability to do contextual learning, which is the next, next wave of AI. That's all going to be intimately tied to the network. So we need to, again, break open these systems in order to enable that. We have to take advantage of cloud computing as a tool to make these efficiencies happen, to make these new approaches to telecommunications happen. So for all this, we're really trying to use this Okudu project as the center point to transform a lot of this industry. So I will end my comments there, and hopefully I've saved some time for questions. I'm sure there'll probably be lots. So thank you. Yep. Questions? Yeah.
Comment about solar winds. You were comparing with open source.
Actually, I was going to, but if you're going to.
You had comment about solar winds. To my understanding, it wasn't the solar wind problem. What they explained was the intern problem, who put the password on the GitHub, I believe. So that's how, like, if I have the more advanced lock for my door, but I put the key which is accessible to everyone. So I think it wasn't a failure of the SolarWinds software itself or the code itself. It was a failure of monitoring the policy implementation and exposing the password to the world. Thank you.
Yeah, fair point. But it's actually a good point, because that could happen for anything. It doesn't have to be proprietary or open. Good management and good governance are required for good security practices. So yeah, either way, yeah, point taken. Anything else? Yeah.
Are you, or is FutureG looking at using open source for strengthening infrastructure deployments in remote and contested environments?
Yeah. So the question is, are we looking at FutureG from the DoD perspective for remote and contested environments? We are, and that's back to our expeditionary and tactical use line of effort, is to try to study that. In fact, we have, working with the Marine Corps is one of our big projects there, At Camp Pendleton, we've been building these expeditionary towers. So you can actually roll these out. We actually have a lot of portable cellular kit these days. We've used them for a number of solutions already. After Typhoon Mawar hit Guam last year, a buddy of mine was he was the second in command of the Air National Guard there. He woke up and the governor had tapped him to fix the problem. And so he went out and grabbed his cell phone, tried to start calling people, and he realized, oh wait, if we don't have a cellular network at this point, I'm not going to get water, not going to get food, I'm not going to get resupplies. So getting cellular communications up, or at least communications of any kind up, became his #1 priority. And so we actually deployed some of our portable 5G gear out there, set it up, and helped them, kind of help them understand communications and ensure that rapid response and independent control of our communications in the military was there. So that's one version of this, and we've used those kits for, I think it was over half a dozen different exercises this year out in the Pacific. And then with the Marine Corps at Camp Pendleton, so there's the vision that they have is what they call Expeditionary Advanced Base Operations, EABO. How do we make sure the Marines can move around within a very short amount of time, like a few numbers of days kind of thing, and be able to pop up anywhere, establish presence, do what they need to do as Marines, which is usually break things. And that can be a good or bad thing, depending on which side of the fence you're on. But they need to be able to do that. They need to be able to communicate. They need base defense systems. They need persistent surveillance. And they need to be able to establish all that quickly. And so the work is to build a portable, so they can roll it out with them, put up a mast, kind of instant connectivity, and systems around there can communicate and work with them in that area. Now you start thinking about this from what does this look like from an RF signature perspective? Can we track these systems because they're broadcasting 5G? Well, you got to broadcast something, and eventually somebody's going to figure out where those photons are coming from. So can we use this to work within existing spectrum? Does that actually help? Do we have to work with our own spectrum in order to provide different types of protections? Do we have to use different types of radio at the edge? And so that's one of the things that we've been working on this Latvia project has shown that. There is a interface called the non-3GPP interworking function, or N3IWF. And commercial industry was interested in N3IWF because they want Wi-Fi to be a native physical layer in their cellular solutions. Because if I bought all this spectrum for billions of dollars over here and I have all these users wanting to use it, if I can offload some of you to an unlicensed band and put you on Wi-Fi and you're not going to notice a difference in the quality of service, I'm going to do that. So they had a vested interest in creating that opportunity. We looked at the N3IWF and said, well, I can also plug in my tactical radio into that interworking function. And now I can key up so my physical layer is the tactical radio that we've built for very special purposes of military use. For protection, for anti-jam, for low probability of detection and interception, all those militarized terms of what we try to do to protect ourselves in a contested environment. Now I can utilize that as my physical layer, but I'm still using a 5G core network for all the management configuration, high capacity inside that network. And so we actually showed over the course of the past couple of years working on this, multiple different countries, homegrown radio solutions communicating with each other. Because you have to normalize the application layer, so we were just using a thing called TAC, or it used to be called the Tactical Application Kit. I think they changed the T to the Technical Application Kit or something. And it's an Android-based app, and so it speaks the same language. But from that application, utilizing an IP network, and now the physical layer is whatever physical layer we tie into this N3IWF, all works seamlessly. So from that perspective, yeah, trying to understand what are the challenges out there in the field, how do we have different use cases for this, and really what it comes down to is what's the risk profile, and can pulling out my 5G phone and tying it to the network, does that fit my risk profile? In a lot of cases, right now, yes. In actual kinetic wartime cases, maybe no. And so how do we actually maintain knowledge of that and options to allow commanders to make informed decisions for when maybe we stop being able to use the 5G signal and have to move to these much more specialized waveforms that we built for us. Does that answer the question? Yeah, Justin.
What about using NTN as an alternative to these mobile base stations?
Yeah, so NTN, non-terrestrial networking, as an alternative. I think they have to be a combined solution. Right? So the challenge with NTN is it's going to be a while, maybe never, for it to have the same types of capacity, to overall bandwidth capacity to manage all the traffic in the field. We look at NTN as either as part of real expeditionary operations where you do have a one lone soldier in the field somewhere and needs to get connectivity. Current NTN solutions and over the next few years going to work fine for that. We also use it a lot for backhaul. So you have a local 5G bubble with all of the capacity and bandwidth communicating around there. You've got all that local compute now that you can bring to bear on this. And now all you really need to communicate back is a much smaller, decisions. So not the raw data, but decisions made off of that data. And then those pipes again become really heavily usable. And then there's going to be variations in between of how we use that, especially at sea. So we've been putting, we've been helping put Starlink on Navy ships and making sure that they have access to critical information and again, that ubiquitous, instantly available information. So yeah, it's going to be, NTN is a big part of our future solution space. And we're working with the Defense Innovation Unit right now to kind of kick off a new NTN effort, so make sure that we're kind of understanding all the possibilities there. So absolutely part of the solution, but I think it's going to be part of the solution, not take over for it. Yep.
Just a question on your great effort for commercialization for MNOs like us. One thing we want to make sure that actually happens is that it's actually apple to apple. I get it, like right now it's MVP. So as we get to the next phase, I'm not sure how much input you got from MNOs like us, but it'll be good if we can get engaged on that front because this is really a game changer, right, from the cost standpoint.
Yeah. Yeah, so the question was basically from an MNO's perspective, how do we make sure that, there's an apples to apples comparison or that you're getting the technology solutions that actually meet your requirements? Yeah. Absolutely. So we should just talk more. I absolutely agree. We have talked, I regularly talk to most of the US MNOs and a few of the international MNOs. And so there are some efforts to ensure that we're trending towards alignment there. And again, back to that kind of timeline slide that I showed you so that there is engagement and understanding of what's required and that you all have the time to analyze it yourselves and make sure that it does fit your needs. So yeah, I think it's, the answer to that is more communication.
So in these tactical environments, power components, I'm assuming they've been offline for a while. So do you assess the risk of turning them on and the ability of them being attacked by the latest vulnerability?
Yes, so the whole risk management, that is a huge part of what we're thinking about. I always say it's one of the key things here is what does your cell phone do when the first time you turn it on after being in an airplane? It just starts screaming, "Somebody please find me," which is like the last thing I want for a lot of these operations for an EABO type scenario. But there you make a good point, kind of the cyber vulnerability is what might happen in the meantime. And so yeah, and that goes back to some of the workforce development concepts that we have. So we need a lot more in the workforce from multiple different levels. We need the people who are in this room who are trying to invent and design the next generation of concepts. We need the academic research world to keep supporting that. We need the base trained engineers to become good solid network engineers in the field. We need the tower climbers. We need the people who can roll these systems out. In all of those different stratuses or layers of this puzzle, we're lacking in a workforce in this country. So we're trying to incentivize that. Within the military, I'm trying to do this because, again, I'm coming from the DoD. I need to make sure that we're solving problems that our equities demand from me. So I'm looking at this we got the same problems, and we need to have a trained workforce within the DoD in order to be able to leverage these systems and make well-informed decisions and understand when we say this is the risk that we have, that there's people within the services that can translate that risk into what's the right decision to make here. So to start that, I've actually brought in, or I built a relationship with the Michigan Air National Guard. The Air National Guard provides about 90% of the comm support for big Air Force. So if I train the Air National Guard to become 5G users, then they get deployed with Air Force and become their communications support experts and now get to have better use in the field. So making sure that we have that kind of workforce knowledgeable, and they're actually up in, they were out in Idaho last week doing some of their initial training. While we're running our system in Latvia, they're going to be up on one of the northern ranges in Michigan doing some of their experiments there so that they can kind of learn again, what does it feel like to deploy this? What does it feel like to use it in the field? What happens when things go wrong? How do I correct these things? If we're really ambitious, we'll turn on some jammers and actually get some hands-on experience with jamming. Right now we basically just say, hey, you're jammed so you can't communicate. That's not how jamming really feels in the real world. So getting them that kind of experience. So that's how I've been thinking about this, is trying to make sure that we have that kind of training and built-in expertise across the services. One more? Actually, sorry. Go ahead.
So you mentioned that there's a lot of fragmentation in the tactical radio systems, around the world and even within the U.S. Do you foresee 5G or some future version supplanting some of these and reducing the fragmentation, with of course enhanced to be more resilient to the...
Yeah, so the question was, with the fragmentation of the tactical radios that I mentioned, that every service or every unit, even in every country, can have its own different tactical radio that has a different protocol and proprietary waveform and things like that. Do we foresee that 5G kind of takes over for some of that? Yeah, I think we do see that. For the majority of our operations, we don't need what those radios bring to the fight. But again, we'll need to have that experience to understand when do I put my phone away and when do I pick up that brick. And maybe it's just to bash somebody over the head, or maybe it's to communicate, but big systems, big batteries, really rugged, robust for all sorts of reasons that the military needs. So yeah, I really do see that a lot of these problems and challenges we have with frequency coordination, configuration management, supply chains and costs, all of those things I think can be mitigated, not fully replaced, but mitigated with understanding how to utilize this technology securely and robustly. So yeah, and maybe there are some enhancements in resiliency that we could add to this. We are looking at a lot of those. In many cases, again, we don't really need them. In fact, one of and I'll end with this. When I kind of took over this job, or was about to move over to the Pentagon and take this job, there were a lot of people that said, really, Tom, are we going to really send our soldiers out into the field with their cell phones? And I looked at them and I said, it's too late. They're already doing that. Let's figure out how to make them safer. So yes, these are bound to take over because it's just what we're so comfortable with and using. So, all right. Thank you again.
Thank you again.